listening to the Futures Podcast with me, Luke Robert Mason. On this episode, I speak to former NASA astronaut Kathy Sullivan.
Sending humans is the boldest, toughest, grandest challenge and can produce the widest, richest array of benefits back for life on Earth.
Kathy shared her insights into what it was like to be part of the NASA team responsible for the launch of the Hubble Space Telescope, the scientific and societal importance of space exploration, and how to create the ideal conditions for innovation to thrive. This episode is an edited version of a recent live stream event. You can view the full unedited video of this conversation at futurespodcast.net. Former NASA astronaut Kathy Sullivan is an extraordinary individual. She is the first American woman to both walk in space and to reach the deepest known spot in the ocean. In her recent book, Handprints on Hubble, Kathy chronicles the incredible feats of engineering, ingenuity, and innovation that led to the launch, rescue, and repair of the world's most productive observatory, the Hubble telescope. Now, Kathy, you've undertaken some astronomical, and pun intended, feats in your life, but I have to ask, what is it actually like to step out into the vacuum of space?
Well, it's rather more like swimming than stepping, Luke. It's, you maneuver with your hands on a spacewalk. If you're working around the space shuttle or the space station, the dozen lucky souls that got to do a spacewalk on the moon could actually be said to step out of their spacecraft. But the rest of us sort of glide out or swim out. And a lot depends, your first impressions will depend a lot on the orientation of your spacecraft. For the shuttle, we often were flying with the cargo bay pointed down towards the Earth. And as it would come out sort of lying on your back to reach your safety tether. So for many people, when they first pulled themselves through that last bit of the hatch, you had this instant feeling of looking very closely at your hands and then suddenly seeing the Earth 200 miles away, which made some people feel like they were falling over a cliff. I didn't have that physical sensation of any tumbling, but it is quite a dramatic thing when your field of view goes from this to that in a fraction of a second.
Now, many astronauts report that overview effect from the awe of being in space. Did you have the same sort of experience?
I think it certainly has some kind of overview, an expansive effect on everyone. I've mused ever since my final flight, what mix is it of just being 200 miles above the Earth, which is clearly a dramatic and pretty radical perspective. But to me, there's also the reality of the journey you took to get there. And, that journey of training, of skills development, of overcoming hurdles, of in many ways, expanding and deepening your own character, that to me has to be part of why getting there has the kind of transformative effect that it does.
Now, you logged over 532 hours in space, almost 23 days. What is the long-term impact of that on both the body and the mind? Does space travel, especially under extended periods, does that have a certain physical effect on you?
On the durations that I was aloft, either each one separately or together, there's really no cumulative physiological effect. NASA does keep tabs on us medically to just look for long-term things that may emerge. But 5, 7, 10 days are short exposures separately and together. The people that are living and working on station now, spending months at a time, sometimes a year at a time, you've got to be alert to a different set of physiological and medical issues. Your longer exposure to high levels of radiation that you get in the Earth's environment. What does that do in terms of cell mutation or damage to the structures of the eye? Progressive and continuous leaching of calcium from your bones. Does that end up leaving you sort of net weaker in your skeleton, maybe more prone on a simple slip and fall accident on Earth? Maybe that becomes more dangerous to you, more damaging to you than it would be to someone who had not had that. There's some interesting shifts that seem to be happening around the optical nerve that I think are not yet well understood. And people who do a lot of work in the spacesuit out on spacewalks, just because of the physics and engineering of how the suit works, especially at the shoulder, some of them are coming back with some shoulder damage.
I mean, it feels like there's so much physical risk to being out in space. And of course, we have bodies, human bodies that evolved for a very terrestrial environment, not for this extraterrestrial environment. Does that make you think, in actual fact, this whole human spaceflight thing is something we probably shouldn't be doing? Or do you think there's actual value in pushing the limitations of the human body in these extraterrestrial environments?
I'm much more in the latter camp, both because of what it may reveal to us and help us understand about the human body, not just to determine if it could be really maintained healthy or adaptable to long-term zero G exposure, but there are functions and processes within the body that we get to look at through a different lens. We get to see them without the consequence or the distortion or the overlay of gravity. And there's potential value there to revealing subtleties of the physiological process that we've not been able to detect here on Earth. And the companion to pressing the human challenge frontier is just the total technical challenge of mounting these missions and sustaining a productive human presence in orbit or someday maybe on another body like the moon. That will require us to make such large advances in such a wide array of scientific and technical fields that I am fully convinced we will see, as we did following the Apollo program, a really rich cascade of benefits back to life here on Earth as other scientists and practitioners and engineers look at the step forward you made in computing or that you made in telemedicine. Say, now that you've made it that powerful or that small or that light, I could now use that over here and transform some earthly application. The digital computers we're talking on today, to me, are a great example of that. The Apollo program was, I would argue, one of the most important and indispensable catalysts in creating the digital computer age. Only the challenge of going to the moon required such computing power at such reliability in such small weight and volume. No such challenge had come along before. And so if you look back, you'd notice Apollo marks a transition from when people used to brag about how big their computers were because that suggested power to what we brag about now today. How much computing power do you have in something this big? Really very much spawned and catalyzed by the demands of Apollo, but utterly transformative for our lives here on Earth.
I mean, that feels like one of the most compelling arguments for why space exploration actually matters, because we learn so much from these space missions that we can apply back here on Earth. And I'm reminded of NASA's spin-off reports, these beautiful reports that they publish annually and have been publishing annually since 1976. And they profile all of these commercial technologies whose origins are in either NASA missions or NASA research. Were you involved in any of that specific research that has now contributed to life back here on terra firma?
Certainly was. And we never had time to be careful students of all the spin-off publications. We sort of leafed through them like the glorious coffee table books they can be. But one that comes to mind is I was on the second of what became a series of three spaceborne radar mapping missions. Synthetic aperture radar is the particular term. And that now, that technology was advancing pretty rapidly. The shuttle missions were very helpful, quick turnaround, learn something, adapt, update, fly it again, learn something, adapt, update, fly it again. They played a catalytic role in advancing the commercial remote sensing that we have available to us now. So that would be one example.
On reading the book, I'm trying to work out who is Kathy Sullivan. Because on one hand, I understand that you're this explorer, this excited adventurer, and on the other hand, you're a very stringent scientist. So what is it that motivates you, Kathy? What motivates you to undertake these epic journeys and embark on these high-risk missions? Is it the science or is it the exploration?
It's very much a combination, a melding of those two. It is for me an intense and boundless geographic curiosity in the broadest, richest sense of the word geographic. So, what is our planet? What is it like? What are the landscapes? What are the cultures, the peoples, the languages, the social and economic flows that make the human dimension of that all work? Every bit of that fascinates me and has done since I was a very young girl. So when I threw my hat in the ring as a candidate to join NASA back in the late 70s for the shuttle program, the strongest personal driving motive for me, it was certainly not the adrenaline or not the adventure. I'd grown up admiring the space program, so there was a factor there. But the biggest factor was if I somehow got selected, against all of the odds out of the thousands, if I got picked, I would get to see the Earth with my own eyes from that vantage point. And that was the particular bit I really could not resist.
And you were one of the thousands who was selected, and you joined NASA in 1978. And before you got the opportunity to break through into the atmosphere, you had to first break through the glass ceiling. So, what was it like to, as you say in the book, stand out amongst the 35 new guys?
That was pretty fascinating. It was unlike anything that had ever happened before in my life. I was straight out of graduate school, so you've been a student and then a college student and then a PhD candidate, and suddenly you're this shiny new toy very much on the national stage and in the spotlight. We were all, I think, shocked at the kind of reaction that we got and the attention that we got. The breaking through the glass ceiling bit, an interesting point there is, in some ways, the fact that we walked into the National Aeronautics and Space Administration carrying the title astronaut meant that we'd already been catapulted through the glass ceiling. That's the prestige role in the agency, the most visible ambassadors, cherished, coveted kind of assignment, great appeal to the public at large. And so it would be like walking into the military, I guess, with the stars, 4 stars of an admiral or a general on your shoulder. I think we got some easier running room and a sort of more of a grace period accorded to us because we arrived with that stature than might have been the case if we joined NASA as a very junior researcher and we're working our way up through that ladder.
I mean, it was obvious to NASA and internally how important you were, but in terms of the media, I mean, there was a lot of media attention around the fact that you were one of the first female astronauts. Were there any mentors at NASA that helped you navigate that media attention?
But back in that day, we were not given a media training course per se at the start of all of this. In fact, the day that our class was first introduced publicly was a massive media day. So here's the bunch of us, the 6 of us women ranged from 26 years old. Sally Ride and I were 26 up to 39, but none of us had had this kind of exposure. The one bit of coaching we got right before the barrage hit was from a senior scientist at NASA named Carolyn Huntoon, who I talk about in the book. And Carolyn had just the kind of presence of mind and care on our behalf to take us aside the evening before and just try to calibrate for us what's going to hit you tomorrow and what sort of consequences and implications of it you might want to think ahead about. For example, you're here as astronauts and see yourself as professionals. The media is also going to wonder about and probe every single angle of being female, from are you the sweet little girl type? Are you dressy? Do you date? Do you do makeup? I mean, all those elements of a classical feminine stereotype, they're going to want to push on you or try to fit on you or try to elicit from you. So just be aware of that. I mean, don't expect they're going to ask the guys just about rocket ships and engineering and flying. They're going to ask about lipstick and makeup and who you've been dating. And just, be aware that's what's coming. And she was dead on.
Well, did you actually learn anything during that period of time that surprised you in terms of the fact that you realized that there's certain things that maybe women have an advantage over men when it comes to going to space? Was there anything there that you suddenly realized, in actual fact, maybe we've got an advantage over the guys here?
Well, some of those normal disadvantages that one thinks of on Earth, like brute muscle force, are leveled out. I can move a 350-pound spacesuit with 2 fingertips, and so can you. So, brute muscle force matters much, much, much less when you're working in zero gravity than it does on Earth. The one advantage, and I sort of had known this from some of the following of the earlier space program, and in fact, part of the rationale back in the 60s for Alan Lovelace to examine a bunch of female pilots and see if they could pass the Mercury qualification tests, the famous Mercury 13, was that providing enough breathing gas, oxygen and nitrogen, for a crew of astronauts depends on how long they're going to be there, what's their breathing rate, and how much lung volume do they have. Well, women should be inherently advantageous in that regard because on average, they have smaller lung volume. So if you were needing to design a life support system for a crew, you could cut X percent of the design challenge out of the way if the crew was all female instead of male, or partial female and male. So it is a mixed bag, obviously, of some puts and takes in both directions. I would say overall, I found where I had to confront barriers or issues were more about my knowledge base, my skills, my strength of character, more than specifically anything that was being thrown in my face that was specifically and explicitly gendered, with the exception of the makeup kits. Because the men have a shaving kit with the razor and all that. And of course, a bunch of 60s vintage male engineers are scratching their chin trying, what do you think the women need in their personal toiletries kits? And they fantasized this amazing array of things, which we then encountered. And most of us said, no, really, yeah, you can put that away.
Anyway, well, you were famously part of the 1990s Space Shuttle Discovery crew who launched and deployed the Hubble Space Telescope. Now, why was this such an important mission? What was so unique about this particular launch?
Oh, it had a long historical root to it, dating arguably back to at least 1946, where the first practical version of the idea emerged. It had been a decade, 2 decades almost in development, in and out, and battled through countless political and budget skirmishes to stay alive and get built. And it was really going to be quite a revolutionary instrument. It was quite a large mirror, 2.4 meters, 8 feet in diameter, the largest optical telescope that had been put into orbit ever. So it was going to be able to see further and see dimmer objects than anything on the Earth could do. Its view would never be blocked by clouds, never be blurred by the turbulence and dust and debris in the atmosphere. And importantly, there are wavelengths of light that are emitted from stars and galaxies that we can't observe from the Earth. The ultraviolet light does not reach the Earth. Our atmosphere is basically a wall that blocks that. So to be able to study stars and galaxies in a wider range of wavelengths with very long durations of exposures were all promised to be quite revolutionary to astronomy. And it just had been waited for so long and had been so hard to bring it across the finish line. All of that added to the magic and the import of the moment.
I mean, what was the atmosphere at NASA like during this time? Because quite famously, NASA was recovering from the Space Shuttle Challenger disaster just 4 years earlier. And you so beautifully chronicle that experience in the book. I just wonder if you could share some of sort of your experiences of that time at NASA.
Well, on a personal and human level, everyone was just devastated. I mean, we lost 7 people. 4 of them were my classmates. The 5th full-time NASA person was one of my favorite people from the next group down, plus Krista McAuliffe and Greg Jarvis, who had secured one-time seats on that flight. Greg famously had been slipped from an earlier scheduled slot into that one for a variety of reasons. So all of that was just completely horrible. And then there was, we're supposed to be better than this. We have to be better than this. This is the outfit that supposedly knows how to do this. How could such a thing happen? How could it? What got by who, where, and how do we make sure it never happens again? If you step a little further back, Hubble and the shuttle really evolved contemporaneously in the, say, mid-70s onward, and in a lot of ways developed a mutual dependence. The shuttle was a big engineering feat and exercise. Part of the argument and contention arguing against it in its development came from the science community. NASA's going to spend all its money on this engineering to go haul commercial satellites, and what's that going to do for us as scientists? And the Hubble was an iconic example that NASA could cite to say it will make scientific payloads like this possible that are really never been possible before. And we can assure you a very long lifetime for these large payloads because we have a vehicle that can go back multiple times and take astronauts and spacewalkers with tools that can repair it or refuel it, or if need be, bring it back to Earth for more substantial repair. So that twin promise of really expanding the capacity of science in complexity and scale and duration, and then the Hubble validating that the shuttle was a real boon to science. There was a real interplay there that was vital at different points in time to the political survival of both. So you just lost the shuttle 4 years before. Here's the signature iconic payload that has been the raison d'etre for the scientific support for the shuttle. It's finally going to get up there. And so that led to a lot of buoyancy, a lot of exuberance to the celebrations around Hubble being launched. And of course, not many weeks later, something on the order of 8 weeks later, when the technical teams discovered that the telescope actually could not focus properly, all of that same energy and all those same factors led to that discovery being almost as crushing as the loss of Challenger. And there were those in the Congress and in the media, right when that became clear, that speculated that this might actually be the death knell for NASA. You blow up a spaceship and then you screw up a telescope, and what else? What can we trust you with? You can't do these things.
Well, in many ways, Kathy, you perhaps helped save NASA's future in space, because you had some very specific responsibilities with the Hubble telescope. Could you just share a little bit about what your role in that mission was?
Sure. The real cornerstone of my role, along with Bruce McCandless as the two spacewalkers, was to look at the telescope from a maintenance point of view. It had been promised it could be maintained in orbit. What does that really mean? And do you actually have all of the tools and other supporting equipment that you will need to deliver on that promise? This came against a backdrop of three earlier satellite servicing missions in 1984 and 1985. Each were done against a satellite that had not been designed and intended for maintenance. And in each case, a minor little omission in one of the engineering drawings almost caused the repair mission to fail. So we now look at Hubble. We're the last two spacewalkers that have it on the ground. We can get at it, we can touch it, we can work on it. And Bruce and I took it as our job to make sure that every single tool that would be needed to repair Hubble was built and tested and proven on the telescope itself. It fits where it needs to fit. It works the way it needs to work. All that had to be done before we put it into orbit. And at least a pretty detailed outline of all the support equipment and the choreography of spacewalks needed to be done. So as I put it in the book, I never flew on one of the missions that actually repaired Hubble. But Bruce and I, with the team of engineers that we worked with, laid the foundation stone on which all those repair missions stood.
And during those foundational moments of working out how to engineer this problem, you say that you learned that both innovation and maintenance are, in a funny sort of way, strange bedfellows. So what do you mean by that? In what way is there a relationship between this thing called innovation and this thing called maintenance?
Well, we do think of them in day-to-day life as quite separate. Innovation is the fancy, sexy, cool thing we all want to be part of, and maintenance is the terrible way you have to spend your Saturday when the sink has been leaking. But when you're designing something to be maintainable and trying to make that real, it turns out they're twins. They're intertwined. Virtually none of the tools that we were going to need for Hubble existed. Or if an analog existed at your local hardware store, it had to be substantially modified to be workable by someone in a spacesuit and in the odd environment and complex geometry of the Hubble itself. And then a lot of things just didn't exist. I mean, if you're a spacewalking astronaut, you're going to crank something open with a wrench. You need some place to anchor your feet so that you can use all the muscles in your body. And if you are going to work on something as large and complex as the Hubble, you're going to need a platform that will fit and be suited for purpose at 40 some locations around the Hubble for astronauts from 5'6" to 6'4". How do you do that? And how do you make something that's quickly adjustable so that you're not throwing away invaluable moments of spacewalking time? Power tools that, yes, you can go buy a drill at the hardware store, but it has some design elements and some lubricants in it that won't work in zero gravity. Earthbound lubricants don't work in the vacuum of space. So how do you adapt that? I could go on and on and on. Spacewalking time is so precious and valuable, and so much was going to need to be done that part of the innovation came in shrinking out lost time and shrinking out weight so you could make things hyper efficient. And then other bits came about because you just never had to grab a certain thing with such a fat, clumsy hand and be sure that you're not going to break it or drop it. What kind of tool will let you do that with low risk?
Well, as a Brit, it feels like NASA is one of these hotbeds for innovation. So what is it that's so unique about a place like NASA that creates the ideal conditions for innovation to thrive?
I think it goes back to something you said a bit earlier. In a sense, to me, it's not about spaceflight per se, but it's about the scale of the challenge. that doing complex things in the space environment represent, because it's the vacuum of space. Because as you go around the Earth, the temperature you're subject to every 45 minutes, it goes from pizza oven hot to Antarctic cold and back again. That imposes all sorts of tremendous engineering challenges. Microgravity, so if things will drop or float. They won't drop, they'll float away with the least little push. So dealing with those kind of challenges, the radiation environment as well, and taking all that on, I need to put machinery up there, keep it operating for a long time, put people up there, keep them healthy and safe and supply them. Those are immense challenges, even today. And so they continually push people to sort of dare to believe and dare to dream. Don't blink and duck at this big challenge, but lean in, get expertise from a wide array together, learn how to work together so that expertise gets melded and meshed and you don't end up in turf fights over who gets to go first. All of those technical and human and social dimensions really get pushed beyond any kind of challenge I can imagine of an earthbound sort.
Just to look at some specific examples, was there anything that you learned during your space missions and your time at NASA that has had, or you've seen had, a direct knock-on effect for how space is explored or interrogated today?
Oh, it's such a vast array of things. It's hard to put my finger on a particular one. I sort of touched on miniaturization and reliability with the Apollo example that I noted earlier on. And that has cascaded through lots of environments. I would argue that the first instance of telemedicine was the telemetry, heart rate telemetry from the astronauts walking on the moon. How do I know these guys are still upright and alive, and they're not taxing their? I don't know how hard it's going to be to work on the moon. What if they start throwing arrhythmias and showing incipient signs of heart attack? What do we do? Thermal and cooling and materials, and just it's too wide an array to pick one from on the fly. Give me a week-long homework assignment. I'll come back with one answer for you.
But in terms of cultural or technical contributions that you personally have made to space, what are you most proud of?
I am definitely most proud of the work that I did to set up the conditions that let Hubble survive to twice its lifetime, and not only last long, but the telescope that's up there today, I would guesstimate, is about 1,000 times better instrument than the one that we deployed in 1990. Because every time a repair flight, a maintenance flight went up, carrying new instruments or new tape recorders or new batteries, the ones that went up were a technology step forward ahead of the ones that had been there. So, the cameras are vastly better. Everything that had moving parts in it, like the early tape recorders for data storage, are now all solid state. More data storage capacity with higher reliability and less weight. The solar arrays produce something like 30% more power with 20% less area. So, the framework is still the same framework we put up there. The tube mirrors are the same. The outer skin is the same. Other than that, just about every other element of Hubble is newer, better, different than it was when we put it up there. And that's, again, all down to the ingenuity around maintenance. And that ingenuity and inventiveness certainly didn't stop with the work that Bruce and I did. By the time the final couple of servicing missions were going up, they were taking on tasks and had invented the equipment needed to do them. The contrast between what we prepared for and what they were doing is like the contrast between changing a tire on your car and doing microsurgery on your hand. So all of that continued to advance through the years of the servicing missions.
Well, the Hubble telescope has revolutionized how we understand our place in the universe. And for you personally, Kathy, what do you think is one of the most important discoveries that this space telescope has made?
Oh, you ask a geologist about grand astronomical discoveries. You're a tough interviewer. The one that really mystifies and dazzles me is, before Hubble, I think it was believed black holes were maybe relatively rare objects associated with quasars. And we've since discovered they're probably at the core of almost every galaxy. And that's still mind-bending to me. I still can't quite wrap my head around how that is so and what all the implications are of that. Gravitational lensing. I'm not enough of a theoretical physicist to have done the math for you, but the notion that gravity bends even light waves, and then to be able to image one star that's behind a massive object and you get 4 representations of that star as a visible proof of what heretofore had just been, a mathematical possibility. I mean, those are just stunning to me.
Well, another icon that you got to spend time with was the space shuttle, and for me, I had the space shuttle toys. I was a '90s child. It was such an icon of the '80s and such an icon of '90s space travel, but it was sadly eventually retired. I mean, how do you feel about that? Do you feel sad about its eventual retirement, or do you think that space trucking, as you've sort of described it, was always going to have a limit?
I was an adult of the '90s and I had a desk full of space shuttle toys, so I'm right there with you. Yeah, I think it probably was inevitable through a combination of factors that are pretty well known. One is it did come to consume a very sizable proportion of NASA's budget. And so you're going to start getting the wrangling about there needs to be some more money for the science. What about deep space and further and bolder exploration? We're sort of stuck in low Earth orbit, as the saying became. And then, in addition, driven by a variety of other factors, and we're seeing this across a wide range of spacefaring nowadays, some elements of space technology did become stable enough and known enough that they commoditized isn't quite the right word, but made sufficiently common that it began to be feasible that private sector companies and private capital could fund and create, design, build, operate systems that had been beyond the reach of any private entity since the start of the space age. But that horizon was now moving. And so the big policy decision, of course, was to transfer the responsibility for moving people and cargo back and forth from the Earth to low Earth orbit, transfer that from being basically a government run airline to being a private sector transport company that NASA would buy services from. It's been a longer road getting there than the optimistic forecast when the decision was made, but it is happening. And there are now several companies and several entities that transport cargo back and forth to the space station, basically for hire, as engaged by NASA and the European Space Agency. And of course, just this past Sunday, we saw the first example of human spaceflight, a crew transferred to and from the space station on a service provision, like you buy seats on an airline, or you don't have to own the whole airline. Doug Hurley and Bob Behnken basically bought seats and flew to the station and back. Operated, controlled, designed by a very skilled team of corporate folks at SpaceX. I do wish, in a perfect world, I would have taken the philosophy that mountaineers and spacewalkers take, which is hook on to the next thing before you let go of the one you've currently got. So I do wish the political and budget decision had been made that NASA could carry on with the shuttle and not have the long hiatus that we did. But the story didn't come out that way.
Well, as the space shuttle retired, you turned to explorations of the ocean, and to me, it feels like you seem to have this weird, unique affinity for cold, dark spaces. Because recently, you went to the bottom of the Challenger Deep, which is the deepest part of the Mariana Trench. Now, what was the reason behind this brand new oceanic mission?
Well, the oceanic thrust was not brand new to me. I began my professional life as a doctoral level oceanographer and a fair number of deep sea expeditions under my belt before joining NASA. So it was sort of a back to the future moment for me, I guess. The opportunity to dive to the bottom of the Marianas Trench landed in my lap unexpectedly, just out of the blue. The gentleman who funded the vessel, the ship that carries this small submersible and the submersible itself, had dived, I think, 5 times to the Challenger Deep last year, or 3 times last year, and had dived to all the deepest spots in each of the 5 major oceans, and was going back to do some more exploration and added science. His name is Victor Vescovo, and he decided that it was high time a woman joined the ranks of people who'd been to the Challenger Deep. And apparently he asked around, I don't know to whom, asked if he were going to invite a woman for this sort of famous first, who should it be? Lucky for me, my name popped up in lots of places. So I was delighted to join him. It was much easier going along as what he calls a mission specialist in the limiting factor submersible than it was to be a mission specialist on the space shuttle, because I had really no formal technical responsibilities to pilot the sub. I was trained enough to operate the manipulator arm if we got near any rocks to pick up. Sadly, we did not do that on my dive. But really, all I had to do was learn a few safety procedures, be ready to get kind of cold as we got cold soaked in the cold, deep water, be pleasant company, and make all the observations I could absorb.
In terms of space and deep sea exploration, did you notice that there were actually any similarities there?
There are a couple of similarities to me and also some very dramatic contrasts. The similarity to me, as from a human experience point of view, is that in each case, I'm inside some, I call them a magic vessel, magic capsule, almost like the children's magic school bus. I'm inside something that lets me go to these places that I otherwise have no business being, and to be in environments that I cannot naturally survive in. It is, of course, not magic at all in the case of the shuttle or the Dragon or the limiting factor. It's just good, solid engineering and science. But it feels magical to me to be able to be in these places, dressed just as I am here, sitting in just the sort of comfort that we're in on this interview, and yet be in this amazing place. The differences are quite stark. It takes 7 million pounds of thrust or thereabouts to get a space shuttle off the planet. It only takes 150 pounds of steel to make the limiting factor heavy enough that it will descend to the bottom of the ocean. It takes you 8.5 minutes to accelerate to orbital speed when you launch in a space shuttle. We were over England in 8.5 minutes on my first flight. It takes 4.5 hours to get to the bottom of the Challenger Deep, which is the same linear distance as about half the length of Manhattan Island. And of course, when you're in the space shuttle looking around, that environment outside your capsule has zero pressure. It's a vacuum of space. In the submersible, it's 16,000 pounds per square inch. So put a huge elephant on a stiletto heel on every square inch of the outside. It's immense pressure. And you look out the window in a spacecraft, you can see basically about 1,000 miles in any direction. And in the submersible, it all depends on how many lights you've carried with you, but we could see maybe about 30 feet.
Well, much like space, it feels like exploring our deep oceans has massive scientific importance. And you actually served as an administrator of the National Oceanic and Atmospheric Administration under Barack Obama. And during that time, what were you finding was some of the most important reasons for exploring our oceans with the same veracity with which we explore space?
The main reason to explore our oceans as dramatically, as intensively as we explore space, is that the ocean is our life support system. The ocean is what makes this planet work and be what it is. It provides half of our oxygen. It drives and tempers our weather and our climate. It's a source of protein, an indispensable source of protein for a huge number of people on the planet. It is the primary reason this earth is as habitable as it is for us and for every other creature that lives on the planet. And we know so astonishingly little about it. Yes, you can go online and find maps that show you the topography of the seafloor, but the resolution of those maps is about 100 times worse than the resolution of maps we have of the moon and Mars. Virtually every instrument, every probe, every submersible that goes into the deep sea sees a critter or something living that we didn't know was there. And at the most exotic end, of course, are the communities, the vibrant communities that live around these hot water hydrothermal vents. When I started grad school, if you told me that we're going to go, 8,000 feet down in dark, cold seawater, and where there's plumes of water that are almost 1,000 degrees centigrade, melt metal spewing out of the seafloor, and the waters become acidic because of all the minerals that they're bringing up. But right there where it's dark and cold and acidic and hot, we're going to find abundant life. You would have been laughed out of the room because it was completely known, air quotes, completely known, that life will be in the ocean only where there is light in the ocean. So here on this planet, we discovered life in conditions that we never before had imagined could support it. And that has carried over into space exploration under the heading of astrobiology. If you find water anywhere, however weird the rest of the conditions might look to you, you may well find life there.
It's just an issue of having to identify that life. In many ways, do you think that, it's so funny, Kathy, listening to you sounds like I'm listening to a Jules Verne novel. It's this individual who explores both outer space and the deep depths of space. But learning that and discovering that there's this almost extraterrestrial life in the deep parts of our oceans. Do you think that that potentially could be one of the most important ways in which we will then learn to identify differentiated forms of life on other planets or other extraterrestrial bodies?
I think it very possibly could be. I mean, this sort of goes now under the heading of extremophiles, creatures, organisms that have an affinity to very extreme environments. So there are the deep sea vents, there are hydrothermal vents and geysers on land. There are remarkable deep rock microbial communities. I mean, meters and meters deep in granite. And again, places that I still can't quite wrap my head around the fact that you've got such communities living in what look like solid rock. That has very much informed and expanded our sense of, where do you look and what do you look for to suggest that there might be life there. It's affected how we look at Mars. It's affected exploratory plans for places like Europa, some of the Galilean satellites and Saturnian satellites. And it's also sort of informed, well, what do you expect to find when you get there? Because it's not about finding small green bipeds that walk up to you and wave, or have a business card. It is more likely about finding microbes or bacteria. Just as here on Earth, the bulk of life here on Earth is microbial and bacterial and insects. It's not the charismatic critters that we tend to think of, but the bulk of the biomass is in those portions of the food chain.
So, Kathy, I do want to ask you about the future of space and the future of space travel, because as you just mentioned, this week we saw commercial space flight programs enable the ability to send men to the International Space Station and bring them back. And it feels like commercial space companies are going to become more and more important in the future exploration of space. But where does that leave someone like NASA's role?
Well, just a small quibble. What we saw was the ability to move people back and forth, and the first two happened to be men. just checking. I think the equation that drives the NASA versus or the public versus private is going to stay in pretty familiar ground for a long time, which is commercial entities may make inroads where it appears to them there may genuinely be a viable market to produce a return on the investment. I'm actually a bit of a skeptic on whether that will prove true even for the low Earth orbit environment. I think certainly NASA, for example, and other government agencies need some means of moving their people and cargo back and forth. They will certainly engage the likes of SpaceX or whoever else comes along. But if that's the limit of the market, then I would argue you don't really have a market. You changed horses a bit. NASA used to own the rockets and hire companies to fly them for the agency. Now the companies own the rocket and NASA buys services. But if that company really only has one customer, it's not a genuinely commercial market. So what will the demand function be? How many people will there be really and when who want to go into low Earth orbit? And what will be the purposes for which they want to go? And if they would love to go and spend a week enjoying zero gravity, well, where will they be able to do that in any kind of number that maybe could come to resemble even an adventure travel service, much less a full up commercial airline? I think the same will apply if you think about, as you look at the potential role for commercial players beyond low Earth orbit. I mean, NASA, even back to Apollo, NASA has never done all of what it's done in-house with government people. It was the Rockwell Corporation that built the Apollo capsule. It was the Grumman Corporation that built the lunar module, but very much to NASA's specification, and the equipment was owned by NASA. So maybe that ownership and specification equation will change a little bit. But for me, it will all depend on whether there truly is a large-scale demand function of multiple users, because that's what would begin to really drive costs down and provide the kind of economic return that could enable evolution of the technology.
Well, I want to ask you about the importance of manned or womaned or personed space flight. And do you think we should be focusing so heavily on getting people into space? Surely as things like robotics get better, it would be easier just to send them ahead of us and then use those robots as our avatars through which we can explore other planets.
Yeah, I certainly in favor of using robots as early scouts and do the reconnaissance. But I remain a fan of human missions for a variety of reasons. And let me just highlight three. The most facetious one is no little kid ever grows up wanting to be a robot. And so in terms of motivation, aspirational, inspirational forces that lift the eyes and lift the sights of our young people, we want to see us doing things. If you know exactly what data you need, I mean, if you really know that, automation can be just great at going out and fulfilling your explicit request. Go get me this, go get me 4K video along this path. But there's so much you don't know. I just think about the dive that I did and the other 5 other dives that happened on the same cruise that I was out with Victor Vescovo. We had a 4K camera looking down at the bottom of the seafloor as we motored along. And there was a goodly bit of information in that 4K view. But on every single dive, the extra eyes looking out other dimensions spotted things that didn't get into the camera that are pertinent to what's down there and what do we need to know about, from some little bits of scientific debris to an organism that just didn't happen to make it into the field of view of the camera. So if you don't know for sure what data you want, then your best situational awareness, take it all in tool is clearly a human being. And finally, the range of technical challenges that have to be overcome to successfully sustain human life on the moon for an extended time or get a crew to Mars and back, that will catalyze a wider array of scientific and technological advances of greater magnitude than any incremental robotic development. And I really believe in the value of that cascade of benefits back to life on Earth. So sending humans is the boldest, toughest, grandest challenge and can produce the widest, richest array of benefits back for life on Earth.
I guess in that case, the question becomes, where do we send those humans? I'd be interested to hear your thoughts on where you stand on the moon or Mars debate. Where do you personally think humanity should be placing its focus in the next 20 years? Should it be the moon? Should it be Mars? Or should it just be space stations, perhaps?
Well, I understand the logic behind the argument that there's lessons to be learned and operating skills to be developed, that it's wise to sort of test run, beta test on the moon. The distances are easier, logistics are easier, delay times in communications. It's a very, very rational argument. I get that. I still worry about we getting stuck on the moon. I'm one who wants to make it unequivocal. And I would love to have a Kennedy-esque kind of speech that said, tell me when we must be at Mars by, and let the engineers decide. So it's a crew on Mars and return by 2040. And if the engineers decide, as they did in Apollo, the engineers laid out the staircase of Mercury to Gemini and Apollo. They were the ones who laid out, these are the smart steps to learn in and grow our capacity. The politicians didn't specify, I want to see 3 different spaceships and do X, Y, Z. So Mars by 2040, and you tell me what we should do on the moon and how long we should spend there, because your assignment is Mars by 2040. I would prefer to do it that way around.
I suppose we did have Robert Zubrin from the Mars Society's speech that Mars is where the science is, it's where the challenge is, and it's where the future is. And if the possibility ever came up that they were looking for a crew for human exploration of Mars and your phone happened to ring, Kathy Sullivan, would you sign up to visit Mars? And would you do it even if it meant there might be a chance of no return trip?
Well, if you sign up to get on a rocket and lift off of this planet, you've already bought into the prospect that there might be no return trip. Okay. Launch risk is not a trivial point. So if you're going to go for the ride at all, you've accepted that you might not come home. So my short answer is yes. It might swing a little bit as it did with the deep sea dive. Who are these guys that are making the invitation, and are they really up to snuff? If they really got their act together, are they credible or reliable, or are they, just bold and crazy people going to try something on a shoestring?
Yeah.
But except for that kind of due diligence, you bet. I'm a geologist. I want to go see those volcanoes.
Well, they're not just the volcanoes on Mars, but we actually have our first question from YouTube, which is from Ben Greenaway, who asks, how about an astrogeologist-friendly question? How realistic do you imagine the mining of asteroids to be?
I would say it's at least decades away, because I think the profits of asteroid mining, I think, really underestimate just the bulk management issues of how much bulk processing you'd have to do to extract what amounts of usable material. If there's a good analysis out there that shows some solid reason to think there's good economic return, I would be shocked. I mean, just think about what most mines on Earth are like in terms of the bulk of mass they have to move to get ounces of the desired metal.
We have another question from YouTube, and this time it's about space tourism. And Kathy, do you believe that space tourism is viable within the next 10 years?
I suspect it is viable in the next 10 years. It depends a bit on can Sir Richard keep Virgin Galactic and Virgin Orbital afloat through all of the craziness of the pandemic, and Jeff Bezos with Blue Origin. I think it's likely for quite some time to be a market that is more akin to extreme expedition tourism, groups that want to ski to the South Pole or commercial expeditions to the summit of Everest. More like that than cruise ship touring, or much less airline travel.
We have another question, this time from Cornelius, who asks, how do you see space exploration develop over the next 100 years? And perhaps I should be a little more kinder to you, Kathy. Maybe let's start with the next 20 years. And if you're feeling brave, then you're welcome to make a 100-year prediction.
At the 20-year horizon, it's plausible that there's a handful of space tourism companies operating in low Earth orbit. There might even be several that have some sort of a temporary stay habitat, glamping in orbit kind of thing. We've got a bevy of spacecraft as of last week that are now on their way to Mars with really quite advanced reconnaissance capabilities on several of them. I really would hope in the next 20 years, if there's not been a crewed mission to Mars, that there's one on the drawing boards and really substantively in work and heading towards a date certain. I'm agnostic and frankly a little disinterested about what's happening on the moon at that same time frame. And I'd love to see some of the advanced probes to places like Europa and some of the icy satellite bodies of the solar system get out there and explore those more carefully. I was debating with myself if I was going to try 100 years.
It's an unfair question, I know.
It's an unfair question,
Well, in actual fact, let me try and ask you the question a slightly different way, because usually the audience question we get is often about sci-fi. And I just wonder, is there any science fictional versions of space travel that you've seen either in text or in film that you think might actually be viable? Are there any space science fiction that you've seen as quite appealing?
Well, of recent space science fiction, one I liked best was The Martian, because you needed to take a little bit of license with how he got into that quandary. But once you did that, I just thought it was such a great expose of how a scientific mind, an engineering mind, would go about staying engaged and trying to think through and come up with and invent and jury rig together some means of signaling. I mean, it was like the scientific method alive on the silver screen, right down to the testing sorts of things, right? I mean, he cobbles together that vehicle to drive over to the abandoned planetary probe. And he has the presence of mind to think, I probably really ought to find out if this contraption can actually go that far. And so he spends those many days just going back and forth right near his camp, sort of mowing the lawn just to make sure it can do the 100 miles. I mean, it's exactly the kind of shakedown test that any good engineer would do.
Well, NASA expects there to be a new class of astronauts very soon. And in fact, I've heard estimates that by mid-2021, they're going to begin training the next class of Artemis generation astronauts. What do you think is in store for that next generation?
In the real world, what's in store for the next couple of waves of NASA astronauts, intended though they may be to be the Artemis generation, will depend on the perseverance and the vision and the stick-to-itiveness of our government, and specifically of whether the Congress is prepared or persuaded to actually devote the kind of resources needed to make that prospect a reality. I joined NASA in 1978. I've had senior policy jobs with every presidential administration since Ronald Reagan. I've kind of seen the Back to the Moon movie about 5 times. It's a glorious vision. I'm always glad to see it. I'm always delighted to hear bold support from the president of my country to continue mounting bold goals in space. But I've also seen it never really get roused up into wider spread public support and never really been transformed into some conviction and convincing of the Congress. So it's a great dramatic moment. It's a lovely day. It's a wonderful press release and great artist renderings. And I welcome all of those. But what I want to see beyond that is the kind of substantive follow-up and persistence that it takes to make it real.
Well, it feels that your current president's vision for space is one of a space force. I just wondered your thoughts on that idea.
Well, it predates our current president by quite a substantial degree and largely originated within our Congress out of some disgruntlement about how prominently space figures within our United States Air Force and the slow pace of getting new systems fielded to operate in space. It also reflects a recognition at senior national leadership levels that there's so many other players active in space now, not only mainly other countries, but not only other countries. And there is a lot of nastiness and game playing that happens in space already. The United States is recognized as being very dependent, both in our civilian economy and for our military operations, on assets in space, satellites of various sorts. And we've designed them for years, for decades now, in a way that presumed and knew that once we put it up there, kind of no one else can get there. There were only, two spacefaring powers, the United States and the Soviet Union. Now there are many. So, the viability and the need to protect those assets that are so critical takes on a different cast in this day and age. So I did my service, our national service, in our Navy. So I'm always willing to throw a little bit of sand at the Air Force. And I worked in the Navy space program. And it always was hard to get the attention and focus on Navy's needs for space because it was just embedded within the Air Force that focused on its own needs. So those intergovernmental dynamics are real. And partly this is an attempt to break those loose and give space its own standing and greater career focus.
I mean, in the US, we've always seen science and politics almost go hand in hand. And Kennedy famously said, "We're not doing it because it's easy. We're doing it because it's hard." It was really a political way in which that America could own the future. If you own space, then you own the future. And it was a response to Sputnik, the idea that perhaps Russia would get there first. But currently, in the 21st century, and since the turn of the 21st century, we're beginning to see the authority of science, and not as a partner of politics, but as something that's being questioned. In fact, we've seen the authority of science questioned or even ignored sometimes at a partisan level in the USA. I mean, how do you think we tackle America's seemingly burgeoning anti-science culture? Is there a way to separate politics and science at this time?
I have no magic answer to that, and it's a concern that worries me deeply. Our country has a long root and historical root of anti-intellectualism. I mean, we're from the European sense, founded by the folks that didn't fit anywhere and weren't highly respected and weren't the leading educated. So that there's a long strain of preference for the common sense of the common man, distrust of authority, or elites that posture themselves as better than you or knowing more than you. I do think we reached a particularly virulent state right now. I could put my finger on a couple of reasons that I think about. One is the spread of digital media and mass media and the pace of the media market. Another is that, science, in the course of my lifetime, science, the trusted science, started as sort of the physics and engineering that helped the Allies win the Second World War. And starting around in the mid-late 70s, more scientific investment began to be applied to public health, human health, the environment, areas of life that touch everybody's life individually. Maybe a part of it is as simple as, when you're just talking about how to do missiles and rockets and things, I respect scientists, count on their physics. You tell them, coming up with something that tells me how I ought to live my life, I'm not so sure about that. So that impingement on everyday life of everyday people is a big part of what connects it more directly to partisan politics. Kennedy connected Apollo directly to diplomacy and strategic advantage in a macro geopolitical sense. But science nowadays is very much more connected to sort of retail politics, if you will, of individual decisions and individual concerns. And I think that makes it more volatile.
Where it becomes a real issue is around things like climate change. I mean, we're not just polluting the planet, it feels like we're polluting space and we're polluting the seas. And how do we look towards the sorts of innovations in science or oceanic exploration that can help us look towards cleaning up our planet or cleaning up our seas and our atmospheres? Do you think there are perhaps scientific innovations or things that we're going to learn from space exploration that's going to directly benefit us here on Earth and teach us how to be more sustainable and live in a more sustainable way with our planet?
I think there may well be such innovations that could be found and brought to fruition. But that depends on developing a stronger consensus. I'm speaking from my point of view on this side of the Atlantic, a stronger consensus that it's important for us to steward our planet better, and therefore to invest not just in more efficient means of extraction or resource utilization, but to invest in lessening our footprint, in remediating some of the effects that are currently present, mitigating the consequences of them. And that's where, in our country at any rate, the consensus is very fragmented, very shaky.
Part of the reason why space is so appealing is because of the lifeboat theory. If we're just going to end up messing up this planet, let's terraform other planets and populate other environments out in space. Are you an advocate of this idea of the lifeboat theory? Do you believe it's important for humans to develop habitats beyond the Earth just in case we mess this one up?
Yeah, I'm not an advocate of that. It comes close to being an amoral proposition to me.
Mm.
We're just throw our hands up. We've given this remarkable planet to live on. We're just going to go with wild abandon, do whatever we want. Then we'll wake up and say, "Oh, that's right, we've trashed it." And by the way, it's a form of the ultimate gated community, right? Because when you say we will need to go to another planet, no one who talks about that means all of humanity. They mean some small segment, some small number of people, chosen by whom, on what grounds, everyone's always a bit muddy about. And the rest of you, poor lot, we're just going to leave you behind in the trash pile that we created. So no, I don't subscribe to that theory.
I mean, I've heard some awful arguments that we need to learn how to terraform other planets because when we mess this one up, at least then we'll have the technology to reverse the damage that we've already done. And you just think, why not stop the damage in the first place? Surely that should be the focus. And that focus perhaps is on the next generation. And how do you feel we should ensure that the next generation has the quote unquote right stuff? That there is so much focus on STEM, but do we need other forms of reform in education to create the future astronauts?
Well, we certainly need some significant transformation on this side of the pond. The achievement, the inspiration and achievement levels of American students are not what I wish they were, certainly. And I don't have a simple answer to this one either, of course, but I do look back at the World War II generation and myself as a sort of early Cold War baby and generation. There was a sense of a really inspiring sense of being someone who built something, be part of creating something big or great or new or different, not just my own company, but to be part of taking on grand challenges that were confronting people. We're going to the moon. And everyone from the janitors at the Johnson Space Center to the astronauts, that's what they felt. We're going to the moon, all of us. The Apollo 11 astronauts themselves talk about their world tour and how stunned they were everywhere they went on the planet. They virtually never met someone who said, "I watched you go to the moon," or "You went to the moon," or "America went to the moon." Everyone said, "We went to the moon." That sort of sense of unity of purpose and unity of humanity, which is another one of the benefits, I think, of the grand, bold spacefaring challenges that involve people. How do we get back to something like that? One of the more demoralizing moments that I've experienced was watching a video of another astronaut speaking to a classroom of young people, 12, 13-year-old, I'm guessing. He's wearing a flight suit and he's talking about, you could be the generation that goes to Mars, to build the spaceship, to fly it there, to do the science. And the camera turns to this young girl. She's sort of, bored, her head resting on her hand, looks very disinterested in all of this. And she puts this lackadaisical hand in the air. And her question was, "Gee, that really sounds hard. Can't I just buy it?" So, how have we imbued in our young folks this sense of all you need to be, as a consumer. So all you need to have is the money to consume, and not that spark, that passion, that sense that it's exciting and gratifying and rewarding and so satisfying to be creating these capacities, not just buying them off the shelf.
Well, I've probably missed the boat to become an astronaut, but perhaps maybe in the future I could become a robot instead, because that sounds a lot easier. But if you were sitting in front of an audience, or there's somebody listening to this podcast right now who has the desire to be an astronaut, or might be enrolling in the NASA program for mid-2021, what one piece of advice would you give them?
Never, ever let anybody edit your dream, and understand the only thing that turns the stardust of dreams into concrete reality is hard work and persistence.
And that's almost a beautiful place to end. But before we do, it feels like you've had this incredible life, Kathy. It's one that's been characterized by taking risks to push the limits of what's possible. And do you think it's important for human beings to take risks in order for progress to occur?
It's indispensable. We have to be willing to push frontiers, to ask what's next, to wonder what's beyond, to wonder what it would take to get there, how we could figure that out. It's essential to human development. I mean, minus the words I just used, everything I just said is what every human infant does from the moment they come out of the womb. It is the quintessentially human process. It is what transforms us from infants into the human beings that we are. It's what keeps us alive. It's what keeps us individually and as a society vibrant. And it absolutely is indispensable to shaping any kind of constructive future.
And on that wonderful note, Kathy Sullivan, I just want to thank you for joining us today.
It's been a delight, Luke. Thanks so much for having me on your show.
Thank you to Kathy for sharing her vision for the future of space exploration. You can find out more by purchasing her new book, Handprints on Hubble, An Astronaut's Story of Invention, available from MIT Press now. And don't forget, you can watch the full unedited video of this conversation at futurespodcast.net, where you can also find out about all of our upcoming live stream events. If you like what you've heard, then you can subscribe for our latest episode, or follow us on Twitter, Facebook, or Instagram at FuturesPodcast. More episodes, transcripts, and show notes can be found at futurespodcast.net. Thank you for listening to the Futures Podcast.